Hi guys, welcome back to my channel. In this video we're going to start on our real world networking project. Okay, so basically I decided to make this class following one of the problems that I received from the students that said, so let me just show you the case study. This was a case study. We are required to design a network in Cisco packet tracer to connect accounts and delivery departments, okay, through the following points. So part A, each department should contain at least 2 PCs. Then part B, appropriate number of switches and routers should be used in the network. Okay, using the given network, this one, all interfaces should be configured with appropriate IP addresses, subnet mask and gateways. Okay, then part D, all devices in the network should be connected using appropriate cables. And finally, we are required to test communication between the accounts and delivery departments. Okay, alright, so guys, following this case study, we are required to design a topology based on the problem that we have seen here. Okay, and in that topology, for the addressing scheme, we are required to do subnetting. Okay, and analyzing this case study, as you can see, how many departments are required? 2 departments, okay, with at least 2 PCs in every department. Okay, so basically in this topology that we are gonna create, we will need 2 subnets. Okay, so let's go back to our packet tracer so that we can begin the configuration. I'll go back to the packet tracer and start. We are required to have 2 subnets, okay, and so I'll need 1 router. That's 1 router, okay, and 2 switches, each for every department. So this is the first switch and the second switch. Okay, and for the first switch, guys, let's say this is accounts. Okay, accounts. And the second switch, we're gonna say this is delivery. Okay, and we are required to at least place 2 PCs at every department. So basically these are host devices, and I will not only place PCs but also other host devices such as printers and other host devices. So the 2 PCs for the accounts, 2 PCs for the delivery, and each department should have at least a printer, you know, for printing work. Okay, so this is the topology that we are gonna have, and in this topology, guys, we are gonna use this topology to implement the case study. Okay, and as you can see, the part D of the question tells us that all devices in the network should be connected using appropriate cables. So let's do the cabling. And in my case, I'll use automatic. So from router 0 to account switch, then from router 0 also to delivery switch. Okay, then now let's connect switch to host devices. I'll do it very fast. This is a very simple project that we're gonna take us at least 30 minutes, and we are done. And we have started from the very basic projects going to much complicated one. So consider this project very simple project. Okay, so we are done cabling. What I'll do basically is to separate the borders, and I'll use that one, and let's choose color. Let's use the purple one. I don't know the color, so I'll say this is account departments, and for the delivery department I'll use let's use green. Okay, so it's done, guys. The topology is done. So basically what's remaining is to implement the topology, and I'll go back to the case study. Design a network in Cisco Packet Tracer to connect accounts and delivery departments through the following. Each department should have at least 2 PCs implemented. Appropriate number of switches and routers should be used in the network implemented. Using the given network of this one, all interfaces should be configured with the appropriate IP addresses, subnet mask and gateways. That will require subnetting. So part D is done, and basically what's remaining is part C and part E. Okay, we have a network of this one, and this is our topology. How are we gonna subnet this network such that all the hosting devices in the network are allocated IP addresses? Basically pretty much simple, guys. We covered subnetting in the previous classes, okay? And basically we've been given a network address of this one, okay? So we need to carry out subnetting, and to do subnetting, guys, we always consider 2 things: how many subnets are needed, or how many host devices in the network are needed, okay? And in our case, guys, considering the case study, we've been told there are how many departments: accounts and delivery department. So I'll go to Word document so that we can do subnetting. Pretty much simple. So we've been given a network of 192.168.40.0. Let me check again if it's correct. Okay, this is the network. Okay, so this is the base network that we are gonna use to subnet. Okay, so this is the network address that we've been given. Okay, and how many subnets are required? So following the case study, guys, we will give subnets much priority than the host devices. Okay, and in some cases, when there are many host devices, you give the host devices a priority. Okay, so in this case, our subnetting will be done considering the number of subnets, and basically the number of subnets here are the number of departments. Okay, so number of departments, number of subnets is equal to 2. After we've known the number of subnets, guys, we can begin subnetting. And basically there's a formula of how to get the number of subnets. It's always 2 raised to power n should give us the number of departments, number of subnets. Okay, so the number of subnets are 2. I'll say 2 raised to power n should give us 2. Okay, so the value of n, let's find the value of n. N is equal to which value that when we place here, and 2 raised to that value will give us 2. Basically it's 1. Okay, any number raised to power 1 is that number. Okay, so n is 1. Guys, this is a very, very important element, domain in subnetting. This one is a very, very important domain in subnetting. So this one will act as a guideline for subnetting. Okay, basically this one here, as you can see it, will represent the number of borrowed bits, the number of borrowed network bits. Okay, so for example, in a normal range, the octets are always 4 octets for the IPv4 address, and in each octet there are 8 bits. So we have, it's always 255.255.255.255. okay, the normal range. Okay, 4 octets, 8 bits. Okay, so in this consideration, guys, we said 1 bit is borrowed for the network part. Okay, so meaning the first octet will contain 8 bits. Let me just count them: 1, 2, 3, 8 bits, and I'll copy, and the second octet also will contain 8 bits. Okay, the third octet also, guys, will contain 8 bits. So on the fourth octet, 1 bit is borrowed, which is represented by this one. Okay, so it's only one, the network bit 1. Okay, only 1 bit is borrowed. Okay, and the other will remain 0. So 1 2 1 2 0. Okay, this one, we're using the number of borrowed bits to calculate the subnet mask. Okay, 1 bit is borrowed, meaning here the 3 octets will have complete 1, and now the last 4th octet will have the first one and the others 0. Okay, pretty much simple. Now let's convert this into decimal. This is binary, so let's convert the binary into decimal. The first octet will represent 2555. The second octet is all are ones, 255. The third octet all are ones, 255. And now the fourth octet, we have the first value as 1 and the others are 0. So based on block size, subnet mask. So 2 raised to power 0, it starts from 0, 1, 2, 3, 4, 5, 6, 7. Okay, we start counting from 0, then 1, 2, 3, 4, 5, 6, 7. So 2 raised to power 0 is 1. Any number raised to power 0 is 1. Then 2 raised to power 1, now the value here is now 1. 2 raised to power 1 is 2. 2 raised to power 2 is 4. 2 raised to power 3 is 8. 2 raised to power 4 is 16. 2 raised to power 5 is 32. 2 raised to power 6 is 64. Then finally 2 raised to power 7 is 128. So this one here represents a block size of 128. So the last value becomes 128. Okay, so this is our subnet mask. This is our subnet mask. Okay, pretty much simple, guys. Very, very simple. Okay, all you have to know is how many subnets are required, and through the subnets that are required, you must calculate the number of the borrowed bits, and you place on a binary form, then convert back to decimal. So I've just converted this number into decimal to get 128. So if you don't know how to convert binary into decimal, research about it, Google, and it will be very, very simple. Okay, so let's begin subnetting. This is subnet mask. So using this subnet mask and a block size, okay, so we say this value represent 128. Okay, a block size of 128, okay, meaning the last octet, when it's 128, it represents a block size of 128. So I'll just go back to the previous classes that we had and show you. I think it's here. So as you can see, when the subnet mask ends with 128 here, the block size is 128. 192, 64, 224, 32, 240, 16, 248, 8, and so on and so forth. So considering these 128, the block size is 128. So the block size basically will tell us how to move from one subnet to another. So the block size will act as a step from this subnet to another subnet. Okay, so the first subnet, I'll start from the first subnet. First subnet. The first thing that I'll do to write the subnet mask. The subnet mask in all cases is this one. Don't forget. So I'll copy and say subnet mask is equal to this. Okay. Then the network ID. So for the case of the first subnet, the network ID will be network network ID is equal to this one. Okay, I'll just copy this one and paste here. This will be the network ID of the first subnet. Start from 0. Okay, .0. Okay, and after specifying the network ID, now let's specify the range of valid host IP address. So valid range of valid host. Okay, now the range of valid host will start from 192.168.40.1 to 192.168.40.26. okay, so the host devices will occupy IP address within this range from .1 to .126. And now finally a broadcast ID. The broadcast ID will be the last IP address to move to the next subnet. So for example, let's say the block size is 128. Okay, the block size is 128. So we are going to add 128 to this one. Okay, and whenever we add 128 to this one, it will be 192.168.40.128. but that one, it won't satisfy the block size because 0 to 128 is 129. Okay, so broadcast ID will be .127. okay, because 0 to 127 is 128 will satisfy the block size. Pretty much simple, guys, pretty much simple. Do you understand? The broadcast ID will be the last IP address. Okay, now the second subnet, I'll copy this one and say second subnet, second subnet. So for the second subnet, subnet mask will remain the same, and now the network ID will be the value of that broadcast, will be the value of block size, which is 128. okay, 128. okay, the block size. So from 0, as you can see, the network ID was 0, then the broadcast ID was 127. So from 0 to 127 is 128. It satisfies the block size, which is 128. Now add 128 here. Basically what you do, you add 128. So when I add 128 here, I will get 256 for the broadcast ID, and this is wrong. So from 128 to 256 is 129. You start counting from 128, meaning the broadcast will be 255. You subtract 1. okay, now the range of valid host ID. Now the range of valid host ID will start from 129. okay, from 129 to the last value, which is 254. So 129, now here will be 254. okay, 254. Guys, it's pretty much simple. It's pretty much simple. Subnetting is pretty much simple. As you can see, guys, here was 0, network ID was 0, and the range of IP address starts from .1, okay, and ends at .126, and the broadcast ID is 127. okay, meaning the range of valid host ID is in between the network ID and broadcast ID. Okay guys, so we are good to go, guys. We are good to go. We are good to start configuring IP address to the topology that we have created. Okay, so let's go back to the configuration part. We are done with the subnetting. Okay, and I will comment for this first subnet. Okay, the network will be 192.168.40.0 / which notation? Let's go back here. I'll tell you something. The subnet mask. Okay, how do we calculate a / notation from a decimal subnet mask? Guys, you change it to binary and start counting this one. 1, 2, these are 8, 8, 8, 24 plus this one now 25. Okay, which give us this one. Okay, slash 25 notation gives us 255.255.255.128. Okay, slash 25. Okay, and now the second subnet will take 192.168.40.128 slash 25. As you can refer back, you can see the network here was 128. Okay, subnet mask is the same. Okay, pretty much simple, guys. Don't forget, this is a very simple project, and from the next project we'll begin on the major and complicated networking project. Okay, so guys, we are done. Basically what you need to do is to configure the devices. I'll start with the router's interfaces. So this is gig 00, gig 01. So I'll start by turning them up. They're in down state by default. No. Then enable config T interface range gig 0/0 to 1. Just configure the same parameter to a given number of interfaces. You raise interface range that and give the range. Okay, hit enter, then no shutdown, do right. Okay, as you can see, they'll turn green, meaning now they are in forwarding state. Okay, they're in hub state. So exit, and let's start from assigning IP address to this interface gig 00. Okay, so it's interface gig 0/0 IP address 192.168.40.0. Then the subnet mask was /25 notation, which is 255.255.255.128. Okay, and you hit enter. Sorry, just that is network, not IP address. So let's assign IP address to that interface. Sorry, I've just assigned a network to this interface. I should assign IP address to the interface. So it's it was the range was from 41. The range was from .1 to 126. Okay, so I'll assign IP address to that interface. I just click on it again and modify. Here should be .1. Okay, and I hit enter. As you can see, guys, now it has picked successfully. Okay, now the IP address of that interface is 40.1 with this subnet mask. Okay, then I'll go to the other interface, which is gig 01. Okay, and assign IP address, which is 128. No, not 128. That is a network. So assign IP address. Don't assign a network the way I did on the first case. On the first case, I mean, I did a mistake to assign a network to as an IP address to an interface. Okay, you assign IP address. So the range of valid IP addresses start from 129 to 254. Okay, so I'll just go back to the same router and say that is 129. Okay, 192.168.40.129, and you hit enter. Okay, and do right. Exit. Now do show start. As you can see, we have assigned IP addresses to the router's interface successfully. And for gig 00, the IP address is this one, 40.1 with the subnet mask. And for gig 01, the IP address of this one, 40.129 subnet mask of this one. Okay, pretty much simple, guys. So what we need to do is to assign IP address to the host devices in the network and test communication. I'll start from this side. We said on this subnet, the range of valid IP addresses, the range of valid host IP address should start from .1 to .126, and .1 has been taken by the router's interface, which will act as the default gateway to this subnet. Okay, so this will take from .2, .3, .4, and the default gateway will be the IP address of this router's interface. The IP address of this interface. Okay, so I'll go to this host computer. and you assign IP address. So go to desktop, IP configuration static 192.168.40.2. okay, now let me copy this. Then the subnet mask, guys, don't forget it was 255.255.255.128. don't forget the subnet mask, I mean, okay. And default gateway, guy, in this case should be the IP address of this interface, okay, the router's interface. Pretty much simple. So paste and .1, it was .1, okay, and all is done. So I'll go back to this PC again and say IP configuration. I'll just paste and say .3, and the subnet mask should be 128.128, and default gateway, I hope you remember. Now the printer, the last device, static, I'll go back to first Ethernet. IP address should be that one, .4, no, .4. Subnet mask should be 128, and now default gateway, come to settings, default gateway should be .1, okay, and you close it. Now you come back to the other subnet, okay, the delivery subnet, okay, and we said for the delivery subnet, which is the subnet, the second subnet, you know, the range of valid host ID should start from .129 to .254, okay, and .129 has already been taken by the router's interface, the default gateway, okay. So these computers will take from .30. So let's click on this one, come to this, come to desktop, IP configuration static. I'll paste this one and say 130. I'll copy that, copy, and subnet mask, guys, don't forget 128, and now the whole gateway was 129. The IP address of the router's interface, this interface, okay, it was 129, okay. So pretty much simple, guys. Don't forget this one will take .31. Don't forget the subnet mask 128, and default gateway should be 129. I hope you remember all those. And finally the printer. So I'll go to config and first Ethernet 0, come to static, paste, let's this take 34, subnet mask for 128, then this one, default gateway should be 129, okay. Alright, guys, so guys, basically let's go back to our case study. The problem said design a network in Cisco packet tracer to connect accounts and delivery departments through the following. Each department should contain at least 2 PCs, okay. Part B, appropriate number of switches and routers should be used in the network. Part A is done, part B is done. Using a given network address of this one, all interfaces should be configured with appropriate IP address, subnet mask, and default gateway. It's done. All devices in the network should be connected using appropriate cables. It's done. And finally, we are gonna test communications, okay. And remember, this simple question is 40 points, okay. 40 points. Very simple, guys, very simple. Okay. So let's do part E, test communications. Close it. I'll try to test communication from this PC to this PC. So I'll take the IP address of this PC and copy it, .130, copy, and try to ping from this PC. Ping, paste, and you hit enter. Just give it time. I believe it will ping successfully. Just give it time. As you can see, all are working, guys. So basically it's very simple. I'll try to ping from this PC to this printer, okay. So let me try to check the IP address of the printer, which is, I come to first Ethernet 0, I copy that, then you come to this PC, PC3, then try to ping, I paste the address of the printer and just give it time, it will ping successfully. Believe it is ping successfully. Guys, it's pretty much simple. What's a little bit challenging here is subnetting. How to do subnetting, okay? Remember, we've been given a case study here, network of this one, and you need 2 subnets, okay? So what to do, guys, you list the requirement the way we have done here. The network address is this one, and the number of subnets are 2. In other cases, you are given the number of host devices in the network, the total number of host devices in the network. So, for example, if you are given the number of host devices in the network, kindly consider the number of host devices in the network. And in the next project, guys, we are going to do a project that involves considering the number of host devices in the network, okay? So, for example, this was number of subnets are 2. And there's a formula to get the number of subnets, which is 2 raised to power n is equal to number of subnets. So, 2 raised to power n is equal to this 2, okay? So, what's the value of n? N must be 1, okay? And that 1 is the number of borrowed network bits, okay? Pretty much simple. And now you write this full subnet mask, the normal subnet mask of this broadcast ID, okay, which is 255.255.255, okay? The number of borrowed network ID is 1, so the 1 will represent the last octet, okay? When we convert this into decimal, you get the subnet mask, which is this one, okay? Alright, and this last value here represents the block size, okay? It's 128. And considering what we've learned earlier, a subnet mask that ends with the 128 represents a block size of this one, okay? Very simple. So the block size is 128. And for the first subnet, you know, subnet mask will remain the same, then the network ID will be from 0. So 0 plus 128, you know, you will get 127. You start from counting from 0 to 127 is equal to 128, okay? Okay? Very simple. You write network ID and the broadcast ID. Then the range of valid host is in between the network ID and the broadcast ID. Pretty much simple, guys. And guys, basically, considering this question here and the topology, we have garnered the full marks because everything is working the way it was asked, okay? Alright, guys, so basically that will mark the end of this project, and kindly suppose you have not subscribed to the channel, do so, because from the next class also we are going to handle some major and complicated networking project that will equip you, and you know, you'll have the full knowledge of Cisco packet tracer networking project, okay? So guys, kindly support our channel, subscribe, like our videos, and drop a comment below. Bye, and see you again in the next project.